This video is going to cover the point-slope form, and you're going to use the point-slope form when you want to find an equation of a line. So it doesn't give me the equation, you have to derive that equation. And what we need in order to use the point-slope form is exactly what it says. We have to know a point. So we could know multiple, but we at least have to know one point that falls on that line. And then we also need to know the slope. So the point-slope form is this: y minus y sub 1 equals m times the quantity x minus x sub 1. In this formula, I'm not expecting you to memorize. The more you use it, the more you will memorize it. But it will be supplied for you. I just need you to be able to use it and know when to use it and how to use it. So when you're looking at the form, what you're going to substitute in for is what the arrows are pointing to. You're going to substitute in for this small m, which we know the small m represents our slope. And then our point, so again, the point-slope form, the slope goes the m, the point goes with this x1 and x1 and y sub 1. So that's where we would plug in the point and plug in the slope. So an example would be find an equation of the line with slope -2 that passes through -11, -12. So let's take that form, y minus y sub 1 equals m times x minus x sub 1. And let's plug in what we know. Well, I know the slope is -2, okay? And then I know that this x1 and y1 is this right here. So the x is the -11, so that's going to go right there. And the y is the -12. Now, again, be careful when you have subtraction in a formula and then you're plugging in a negative. Okay, so make sure that when that happens, you end up with 2 at the end. So what this really says is y minus -12, which is y plus 12. And then we have x plus 11. So I'm just going to simplify it so we can get rid of those double negatives. Now let's go ahead and solve it and put it in slope-intercept form. So let's simplify it down a little bit. So we're going to do that by distributing first. So -2 times x is -2x. -2 times a positive 11 is -22. And then because this plus 12 can come over on this right side and combine with the -22, let's do that. Again, kind of put those like terms together. So then that would give you y equals -2x, and then that would give you a -34. And this would be the equation of that line. So notice the slope did not change. Okay, the number in front of the x, that coefficient is the slope. The -2's match, and they should continue to match. All right, let's look at another. So find an equation of the line with slope 1/5 that passes through 5, -1. So again, let's write out the formula and plug in what we know. So we got y minus, I just kind of like to do it this way, but you can. So the 1/5 goes here for the m. The x is the 5, so that goes there. The y is the -1. So I have y plus 1. I'll go ahead and distribute that 1/5 here in this step. 1/5 times a -5 gives you a -1. And let's subtract it to bring it over, just like we did the last. And get -2. And again, the slope isn't any different. So now we know this point falls on the line, and then we even know that -2 is the y-intercept. But this would be the equation. All right, go ahead and pause and try. Two very similar examples, but write the equation. Here's your slope, here's your point, slope, and point, and see what you get. And I put the equation up there. Okay, let's look at the first one. So I'm going to take and substitute in the 2 here for the m. I'm going to substitute in -5 for the x, -6 for the y. Alright, so that's y plus 6 equals 2 times x plus 5. Go ahead and distribute. Get 2x plus 10. Subtract the 6, and you should have ended up with y equals 2x plus 4 as your equation for this first one. And again, that's just putting the equation into slope-intercept form, which is covered in another video, but it's just kind of simplifying it down. Good. All right, let's take a look at the other. All right, let's look at the second one. Plug in 1/4 for the slope. We got 3 for x and -2 for y. So I'll distribute. Now this one you would have ended up with a fraction for this second part, but that's okay. So so you got 3/4 there. Subtract 2. So you should end up with 1/4 is the slope in front of x, and then you got -2 and 3/4 here. Okay, so it's okay if I see an equation that has fractions, so stick with the process and you're doing it right. Good, very good. Okay, so the next part of this is, well, what happens when you are given just 2 points? So in other words, it doesn't clearly say the slope is something. So this one says find an equation of the line that passes through -4, 0 and 6, -1. Well, I don't have the slope, so I clearly have to have this m in order to plug in for the point slope form. But if I'm given 2 points, I can figure out the slope. So let's do that first. So figure out what is the slope between these 2 points. And you do that by taking the difference of your y's over difference of your x's. So 0 minus a -1. Those are your y's. And then -4 minus 6. That's going to give you a 1 on top, and it's going to give you a -10 on bottom. So your slope is -1/10. So now I know what that m is. So I'm on the track to do it. Well, now all I need for this is a point. Well, you're given 2. It does not matter which one you use. You will come up with the same equation. So I just naturally use the first point that they're given, but you don't have to. So I'm going to use -4, 0. So -4 is the x, 0 is the y. So I have y minus 0, so that's nothing. Go ahead and distribute the 1/10. That would give you plus, that's a -4/10. And that would be your equation. Okay, so again, the only thing changing here is this. I have to do this first step of finding the slope before I can use the point slope form. All right, let's do another example. So find an equation of the line that passes through 6, 1 and 8, -4. So let's find the slope first. So that's y, so that's 1 minus -4. Again, that's these here. And then I have 6 minus 8. That's going to give me 5 on top and a -2 on bottom. So that's -5/2. Okay, so now let's use that point slope form. Slope was -5/2. All right, and again, I'm just going to use the 6, 1 ordered pair. So 6 goes in for x, 1 goes in for y. that's y minus 1. All right, when you go to distribute, that's negative 5 over 2x. Now when I distribute to the second, a negative times a negative is positive. 5 over 2 times 6, that would be 15. Let me double check my math. Yep, 15. And then add your 1. And you get y equals negative 5 over 2x plus 16 as your equation. Again, this is what we're adding, is that first step for these problems. All right, let's try one more together. So let's do the slope first. So negative 3, 5, and 2, 2. So that's going to be 5 minus 2, negative 3 minus 2. That's going to give me 3 on top, negative 5 on bottom. Excuse me. All right, so then we got the slope is negative 3/5. Let's use 2, 2 just for this time. You could do negative 3, 5. I like 2, 2 just because it doesn't have any negatives. So 2 for both. So we got y minus 2 equals negative 3/5 x. Now negative times a negative is positive again. And negative 3/5 times 2, that gives you 1.2 is what my calculator gave me. So 1.2 or 1 2/10 or 1/5, something like that. Then go ahead and add 2. So it's okay if you keep it as a decimal. Either way works. We just typically don't see our slopes as a decimal because we need a rise over a run. But if your y-intercept ends up in a decimal, that's okay. And that would be your final equation. All right, go ahead and pause and try these two and see what you can come up with. All right, so I'm going to do the slope for both of these over here. So we got negative 4 minus 8 and negative 2 minus 1. Again, make sure you're doing your y's over on top and your x's on bottom. Otherwise, your slope's always going to be off. That's giving you negative 12 over negative 3, which actually simplifies to a positive 4. So for this first one, your slope is 4. And I'll go ahead and use, I'll use 1/8 again so I can ignore the negatives. All right, so 1 is your x, that's there. 8 is your y, that's there. All right, so you get 4x minus 4. Add the 8. You get y equals 4x plus 4 as your final equation here for that first one. Okay, very good. Let's look at this next one. All right, so the slope here, so we have negative 1 minus 5 is your y's, and 0 minus 3, which gives you negative 6 over negative 3, which again simplifies to a positive 2. All right, and then I'll use 3, 5. So 3 is your x, 5 is your y. And again, my preference of using for the point does not have to be your preference. So if you use something different, that's fine. Add the 5. Either way, you should come up with this exact same equation for this line, and that'd be negative 1. And that's what we get for the last example. Good, very good. Okay, so now let's put this into practice. This point slope form has some relevant use to some things, so let's look at some of these examples and I'll walk you through what are the steps to utilize the point slope form in this application. So this problem is talking about Window World having 50 employees, and then in 2012 the company had 85 employees, right? So in 97 there was 50. In 2012 there was 85. All right. Let X represent the number of years after 1997 and let Y represent the number of employees. Assume that the relationship between years and number of employees is linear. Write an equation to describe this relationship. Okay, so let's break down some of those last few. So first I want to talk about this sentence here. So assume the relationship employees is linear. Why that's important for us right here, right now, is because we're just dealing with linear equations. If we didn't assume that it was linear, it would change our process. But in this case, we're assuming it's linear so we can use our point slope form eventually to get this equation. Okay, so that's why that's in there. Our ultimate goal is to write an equation. Okay, so another important is this here. So we want to figure out, well, it's going to tell you what are we going to represent X and Y as. So X is years after 97. So years after 1997. So that's what that X value is going to represent. Y is number of employees. Okay, so our step one is to take these numbers, this information that we have, and write these as ordered pairs. So if in 1997 the employees were 50, if I put that in an ordered pair, I know 50 is going to be my Y because that's the number of employees. This can get kind of tricky for your X. So it says years after 97. So 97 is how many years after 97? Well, that's 0. Okay, so I'm not putting 1997 in for my X. I'm putting the number of years it is after 97. Okay, so that's my first ordered pair. My second ordered pair is 85 is the Y. That's the number of employees. That one's easy. So now 2012. How many years after 97 is 2012? So that would be 2012 minus 1997. And that gives you 15 years difference. Okay, so this is tricky. We're going to do some examples. So just try to keep track of that years after. Okay, so step one, write the ordered pairs. Okay, so now that we have step one taken care of, we're right back to where we were in our last examples. I now am looking at two ordered pairs, so let's find the slope. So M equals, so we got 50 minus 85 and 0 minus 15. So 50 minus 85 gives you negative 35, and that's negative 15. A negative over a negative is positive. 35 divided by 15 is 2 1/3. Okay, so it's 2.3 repeating in your calculator. This would be, 7/3 as an improper. And I'm going to use the 7/3 just because slope is, one number over another. Okay, all right, so we ordered our found our ordered pairs, found the slope. Okay, so we did this, did that. Now we're going to use the point slope form. So let's do y minus y1 equals m times x minus x1. I know the slope, again, I'm going to use 7/3. You could use 2 1/3. You would get the same, whatever you would like to use. I'll use 0, 50, so 0 is your x, 50 is your y. That's going to give you y minus 50 equals 7/3 x. 7/3 times 0 is nothing. So I'm just going to leave that as just like that. And then I can add this 50 just to bring it over here, giving you y equals 7/3 x plus 50, because that was nothing, giving you that. Okay. All right, so we wrote our ordered pairs, we found the slope, we used the point slope form, which we're kind of used to. Well, why this is important, and this actually can now be productive for this company, is for something like this number 4, this step here. Use the equation to predict the number of employees in 2007. So 2007, we had our x and our y. X represented the time, right? The years. Y represented the number of employees. All right, so X was years after 1997. So how many years is 2007 after 1997? So find that difference. What's that difference in time? And that would be 10 years. So if I want to make this prediction, I know that my x is going to be 10. So I can use this formula, this equation that we found, and plug in 10 for x. So I could do 7/3 times 10, okay, which gave me 23 1/3. Then add the 50, and you get 73 1/3. Okay, so again, I'm predicting the number of employees in 2007. Well, I'm not going to say I'm going to have 73 1/3 employees, because I'm never going to hire a third of a person. So my prediction would be about 73 employees. Okay, so what we just did, kind of taking this scenario for this company, is that we gave ourselves an equation that we can use to make predictions for the future. Okay, let's look at this one. So this one's looking at a Chrysler. Employees has decreased approximately linearly. Again, that's important. We got to know that we're kind of assuming it's a linear relationship, from 63,000 employees in 2002 to 45,000 employees in 2007. Let N be the number of Chrysler employees in thousands at T years since 2000. All right, so kind of the same generic question as the last one, but let's talk about this and get some clarity for you here. Notice they didn't tell me X and Y. They told me N and T. Okay, let me give you a little pointer. 99.9% of the time, your X value of an ordered pair is always the time. Okay, so no matter what they tell me, N, T, S, V, it doesn't matter. Whichever one is representing time, years, minutes, seconds, any sort of time duration, that is going to be your X. So in this case, we're going to look at T is the X because that's the years, and N. Okay, and that's just a helpful tip, because sometimes verbiage in practice problem doesn't necessarily always give you X's and Y's. So whichever one represents your time goes in for that X part of the ordered pair. Okay, so let's write our ordered pairs. All right, so we had 63,000 in 2002. So I know 63 is going to be the Y, but it says T since 2000. So 2002 is 2 years after 2000. So 2 goes in for that X. Then I had 45,000 in 2007. So 45 would be your Y. 7 would be your X because it's 7 years after. Okay, so this one was a little easier, except that it was the N and the T. So please remember this, especially when you're working on your practice. All right, so we got our ordered pairs. Now let's find the slope. So we have y's over x's. So 63 minus 45 gives you 18. 2 minus 7 gives you negative 5. All right, and again, you could leave it at that, or you could write it as 3 3/10. Yeah, that's what that gets you. Now, while we're here, let's pause for a second. Let's go back a little bit. Let's come back to this problem here. So here we ended up with a positive slope. So that would tell me what about this situation? Well, that would tell me that as time goes on, it's increasing. Now, when we come here, it's always a good thing to stop and ask yourself, should my slope be positive or negative? In this case here, in the Chrysler example, it clearly tells us that it's decreasing. So it makes sense for us to come up with a negative slope because it says it's decreasing. Always make sure you pause yourself and ask yourself, does it make sense to have a positive slope? Does it make sense to have a negative? If we would have came up with a positive, hopefully you could have said, wait a minute, it said decrease, so I did something in my math wrong. I should have a negative. Okay. Oh, yeah. And sorry, that should be 3/5. I apologize. Okay, so we did our ordered pairs. We now have our slope. Let's use this point slope form. All right, so we got our slope. Again, I'm going to use the 18/5. Okay, it doesn't, I'll use the 263, so 2 is your x, 63 is your y. So I have y minus 63 equals negative 18/5 x. Negative times negative is positive. And let's see, 18/5 times 2 gave me 7 1/5. I would add the 63, and that's going to give you y equals negative 18/5 plus 70 1/5. Oh, sorry, I forgot my x there. Okay, so that would be my equation. So ordered pairs, slope, then use the point slope form. Okay, and that's where I'm at right there. Okay, so again, what does this information tell me here within this equation? Let's talk about that a little bit too here. And then you can go back and think about the other one. So this 70 1/5 tells me my y-intercept. So what that tells me here is that, remember that it was since 2000. So this here tells me that in 2000, because that's my starting point, in 2000, there was about 70,000 employees. Okay, so that's what that tells me. Sorry, I was going back to make sure. So 70,000, about 70,000 employees in 2000, because that was the starting point dictated by the problem. Okay. And what this slope is telling you, this negative 18/5, well, that's telling me that it's going to decrease about 18 employees every 5 years. Okay, because remember, we're y's over x's. So your x is your time. So time's always on bottom. Y was, in this case, talking about the number of employees. Okay, so that's just kind of a side note, but think about that. Think about, what do these numbers mean, and can I interpret them? Okay, so if I'm trying to do this last one and make a prediction for the number of employees in 2010, I know that that's going to mean my x is 10 because that's 10 years after 2000. So let's go ahead and plug that 10 in here for x. Right, and that's going to give you y equals negative, I think 36. Yep. And then add 70 and a fifth. And that's going to give you 34 and a fifth. So in 2000, we started here at the 70,000 mark roughly. In 2010, we're going to be all the way down to this 34,000. Sorry, that'd be 18,000. Okay, and again, it makes sense for it to go down over time. Good, very good.